Hey everybody, welcome to the third and last episode of this tutorial series about converting a Shadertoy shader into one of the ways that we have in Max to write a shader. So, those three ways we have to write a shader in Max are these three. So, the first object that we used to write a shader was jit.gl.pix. So, if I click on this and let the jit.gl.pix flow, the first jit.gl.pix called shadcomp flow to the video plane, then we get the shader. Inside this jit.gl.pix, we just use the gen objects. So we recreated the code, this code here from Shadertoy using gen objects. Then the second way that we saw was again inside the jit.gl.pix, but using the code box object. So we recreated the code by using the code box object. As you can see, is much more neat and short than using the gen objects. In this episode, we are going to use jit.gl.slab object. So we are going to see how to write this Shadertoy shader inside jit.gl.slab using the GLSL language. So let's get started. So first of all, what we need is a pass-through jit.slab shader like this one. Now, if you don't know anything about shaders, I encourage you to visit the tutorial that I wrote that is on my website at this link. I will put the link in the description. That gives you an introduction on how shaders work. So once you read that, you will know that this is actually a fragment shader. So on jit.gl.slab, we can work on textures exactly like in the jit.gl.pix object. So when we write a shader inside inside this editor for jit.gl.slab, we need to take care also of this kind of XML structure that allows Max to read and implement the shader. So there is all these three structure that you need to write in order to be able to write the shader. Well, instead of writing all by ourselves, we can just take one of the shaders that come in with Max. So, for example, if we create a jit.gl.slab and say file ccbrcosa.jxs, if we open it, then we have a shader inside this that makes like brightness, contrast, saturation. So, in order to get a simple pass-through shader from that, we can just delete everything that we don't need. So, for example, we can just delete everything that we don't need, like all these parameters we don't need. I will just leave one and all these parameters. Let's leave the image parameter because this is our texture that comes in from outside and which we want to work on. We don't really need this actually, but let's leave it in order to have an example of how to write a parameter. So let's change this name here. Oops. Let's change the name of the shader here in what we need. And let's delete the description also. Actually, the name that I gave is actually the description. So this stuff we can leave it here because this is the vertex shader. This is the vertex shader, so we actually need to transform the coordinates of the object that comes in, of the mesh, which is actually a quad that covers the whole screen in this case. And then we need the texture coordinates. So we need the texture matrix multiplied by the multi-texture coordinates, 0. This will give us the texture coordinate for this particular texture. Let's delete these comments here. This is the fragment shader now. This is now the fragment shader. And let's also delete all these uniform and varying variables. There should be actually, let's leave actually the image uniform, which is, as said, is our texture that comes inside. And then let's delete everything apart from this. So we have now the texture color, which is the texture to direct. This is the function that allows us to read our texture. So the texture is here, is image, and text code are the coordinates that we are passing from the vertex shader, which should actually copy that and paste it also here in the fragment shader. Because this is a varying variable, and as I will explain in further tutorials, but varying variables are variables that get passed from the vertex shader into the fragment shader and get interpolated for every vertex. So from vertex to vertex they get interpolated in order to cover all the pixels that display the shape. So we need the texture coordinates. So instead of writing here that, we can just write text color and then 1.0 for the alpha. Okay, now we are done. We can just go into File and Save As, and then on the desktop we can call this basic slab.jxs. Okay, so now we have our shader, our basic shader on which we can work. We can give the read command to our slab object and read our shader. If we double click, we can now see the shader as we left it appearing here in the editor. The thing is that I would not like to use the predefined editor inside Max. I would like to use Atom because I like it more. If you don't have Atom, you can download it for free from the internet, or you can just use the editor from Max. I will use Atom for this case. So now I have my shader opened in Atom. It doesn't have the GLSL syntax by the moment, so in order to select this syntax, I will press Ctrl Shift and L and then type in GLSL. I remember that GLSL is not a default syntax for Atom. You will have to download a package, but it's super simple. So now everything that is related to the GLSL language is highlighted inside Atom. Now let's write the code for our Shadertoy shader. So the code is here. Let's start implementing that. So first of all, we need a parameter from Max, that is our time. So as we did for the Pix object, we used the clocker object and created a parameter called time inside jit.gl.pix in order to have a continuous flow of consecutive numbers inside our shader. This is what gives us the animation. So we need to have this also inside the slab. In order to do this, let's copy this. Let's actually replace this parameter here because we don't need a texture. We can just call this time. The type is float because of floating point numbers, and the default is 0.0. Then we have to bind the parameter to the fragment shader, so we also have to substitute to replace the name here. Instead of image, let's write time. So now this parameter doesn't exist anymore. We can just replace it with our new parameter called time. The texture coordinates we actually also don't need, but let's just leave them here for the moment. Then we need a resolution. So let's create another parameter. Let's copy that. Param name, let's call this resolution. It's a floating point, and by default, let's put it to 1. So the resolution comes from our jit world object, as we saw in the previous tutorials, and is actually the x side divided by the y side. So it's more like the ratio. It does it inside the shader. It's the x side divided by the y side. So in the end will be like the ratio, but let's pass it as in the original shader. So we pass just the sizes of our window. So the x and y of our window that they change when we resize our window. So this is why there is a qmetro here with a time of 2 seconds, and is always active, and it bangs this getSize message in order for us to update the ratio on our shader, because if I also do that, then the ratio gets updated and our shader gets displayed correctly on the right proportions. So this is why we need the resolution parameter. So let's create this parameter. We created it. Let's also bind it to the fragment shader. So let's do it like this. Program FP. Perfect. So let's copy also that. Let's call this resolution. Okay, perfect. Now we are ready with the parameters. We can start writing our fragment shader. So the Shadertoy code. The main image in this case is this void main in the fragment shader. We don't need the arguments from Shadertoy because these arguments, like the frag color, is an output variable. It's replaced by this GL frag color output variable. And the frag coordinates we are passing from the vertex shader, so are actually the text coordinates. Okay, so let's start writing the code. First of all, let's create this vector tree. You can see that inside the GLSL, the syntax is really pretty similar to the one of Shadertoy. Is actually the same. So we can basically just copy this code in its entirety and see just what we have to change. So let's do it like this. Okay, so now we have vector C, float LZ, and Z is equal to time, which is our uniform here. And then we have a for loop. This frag chord is actually our text chord. Sorry, is written like this. Our text coordinates, and R is actually, it says that is our resolution, but we didn't call it R, we called it resolution. So I'm also wrong, sorry, because resolution is not a single float, it's not the ratio, is actually a vector 2. So we have to write it. We have to write it like this. We have to say that this is a vector 2. So we are now dividing a vector 2 text coordinates for the resolution, which is also a vector 2. Okay, then we have, and this is what gets assigned to P. So we could have actually just write it like this. Back to P, it's equal to that. Back to UV, it's equal to nothing for the moment. This is what it means to write a variable and then with a comma another variable, and what's get assigned in the end gets only assigned to the last variable. So in this case UV is not equal to nothing, but here it gets assigned to P, so it's actually now equal to P. Now to P it gets subtracted 0.5, and the x sides of the P vector gets multiplied for our resolution ratio, so for the x divided the y. Okay, then to z, which is our time, gets summed at 0.07. Then we have the length of P, we have these calculations here, and then we have this array style of accessing the components of the C vector, which was actually empty in the beginning, and now we are assigning to it the result of these calculations. And then we have to replace GL frag color with GL we have to replace the frag color variable with the GL frag color variable. And this should be working. So let's actually try again to read this shader in order to update it inside and we have some errors. So undefined variable t, I forgot to replace a t with time, which is probably somewhere here. Ah yeah, here. We actually don't need this t, we can just put 1.0 because this is the alpha. So let's read it again. And now it seems to work. So let's switch to the last one and it doesn't work. So this doesn't work for a couple of reasons. First, we have to send the parameters that we created here, so time and resolution, to our shaders. So in order to do that, we've also to prepend the param keyword to our parameters. So time prepend param. This is our time parameter, and this is now our resolution parameter. Okay, then here it wants actually not the resolution, the p, it just wants to be normalized coordinates. So if we divide this for the resolution, I show you what happens. If we select our last shader, the shader is moved on an angle of our screen. But if we resize our window, then the situation gets different. So there is a problem here. Now, the problem is that here, as I said, it doesn't want to be divided by the resolution of our window, but from the sizes of our texture. So we can solve this problem in two ways. So one of these two ways is to send the texture dimensions from the from the vertex shader, which is this code here. You can find this code inside the file browser. If you go into Jitter and then shaders, and then you look for true, we have sh pass-through dim, and here you can find the code to get the dimension of the incoming texture, which in our case is 800 by 800. We know this number. We could also hard code it inside our shader, but it's better to use a variable that we can always retrieve from our code. So let's pass this to the fragment shader by using a varying variable. So as we say, the varying variable are variables that get passed from the vertex to the fragment. And let's write its name here, text dim 0. Let's write it also there because we need to write it both in the vertex and in the fragment. And then let's use it here. So text dimension 0. Let's reload the shader and see if it worked. Yeah. Now it is correct because now p is just normalized coordinates between 0 and 1. If we don't want to do that, we can also just use normalized coordinates by default. And in order to do that, we have to assign the rectangle 0 attribute to our texture here. So let's delete this, let's save and reload our shader to see if this worked. It seems, let's do like this. Yeah, it works. So we can either use the texture coordinates from the vertex shader or simply pass in a texture with the coordinates from 0 to 1 normalized. This is what the rectangle attribute means. So with the rectangle attributes, we will have texture coordinates that range from 0 to the size of the texture minus 1, and with rectangle 0, they will range between 0 and 1. So we can do it like that. I will go back to the previous solution because I find it a bit more clean. So let's read again the shader. Okay, so yeah, if we open our slab file, we can take a look at what we wrote. Oops. So it was actually super simple to convert the Shadertoy shader into a slab shader. We just had to replace the frag color variable with the GL frag color and to pass in a couple of parameters. And the rest was pretty straightforward. So, thank you for following this tutorial. There will be some more shader tutorials in the near future, and I hope this is a topic that is interesting for you. If it isn't, just write me, and maybe with some suggestions about other kind of tutorials, and I can take a look and work on other things. But now I'm totally into shaders, so I will do some more shader tutorials. Because shaders are a super powerful tool that we have inside Max and computer graphics in general, and so it's worth studying. Okay, thank you for following. If you want, you can support me on my Patreon or visit my website. I will write both the links in the description. On my website you can find a lot more tutorials and Max patches and stuff. Okay, so thank you a lot and see you soon. Ciao.